In 2004, salvage excavation began in Yenikapi, Istanbul, under the supervision of the Istanbul Archaeological Museum Directorate. These excavations revealed the Theodosius Harbor, one of the most important commercial harbors of the Byzantine period on the Marmara Sea coast. The remains of 37 ships were unearthed, scattered throughout the excavation area. Due to the rapid coverage of these ships by the alluvium carried by the Lycos stream and the sand brought by the sea, they have been remarkably well preserved to the present day. The ships are preliminarily dated between 5th and 11th century AD. The Yenikapi shipwrecks constitute the world's largest collection of medieval ships. Among this collection, the Yenikapi 16 shipwreck is a galley-type vessel dated to the 9th century AD. No other archaeological example of this type in such a well-preserved condition from the 9th century exists in the world. For this reason, detailed documentation of the galley, the creation of 3D images, and obtaining visual data about the wreck in an understandable way are of great importance for the preservation and transmission underwater cultural heritage to future generations. In the post-excavation documentation of archaeological ship timbers, three-dimensional digital documentation is essential for accurately and quickly recording artifacts as objectively as possible and with micron precision. The highest level of accuracy can be achieved by documenting each piece at full scale. All the individual ship components were documented in 3D using Forearm, a 3D contact digitizer device. Rhinoceros 3D software was used to capture point data from the forearm of the Yenikapi 16 wreck and to create digital solid models of the timbers. The software interface provides a multi-view screen that offers both a 3D workspace and 2D views. Within the device, 25 different elements such as tool marks, section and plan views, wood and metal fasteners, wood grain, damaged parts, and original joints, which can serve as references for determining shipbuilding techniques on wooden elements, were evaluated and recorded in different colors in the Rhinoceros program. In total, 208 ship components of the Yenikapi 16 shipwreck were recorded, and models were created through the study. 9 of the frames, which had high water content and intense deterioration, could not be modeled. For each ship component documented linearly, 3D solid models were created with the help of Rhinoceros software. Once the modeling phase was completed, the file was simplified by redrawing the existing drawing. A separate model of each surface was created based on the simplified drawing, and then all these surfaces were combined. The 3D models obtained from the one-to-one scale drawing made with the forearm device were aligned with the drawing obtained with the in-situ total station drawing. With the data generated, a 3D model of the in-situ Yenikapi 16 shipwreck measuring 22.5 meters in length and 2.4 meters in width was produced. A scaled physical research model of the original boat form can be made using the digital solid model obtained by creating comprehensive and detailed digital data. Additionally, digital and physical 3D reconstructions that will be created in the subsequent phases will serve as guide for the final reconstruction and reshaping of the ship timbers after conservation.